Good morning, good afternoon, good evening. Welcome to this short series, which is a welcome to the majority of you who are joining us today. So, we want to discuss two aspects that have importance when it comes to solar PV power systems. And the person who is presenting to you, I am Dr. Engineer Enoch Mulenga. So, to begin with, we see an illustration of a balance of power of a solar PV system. So, this solar PV system is made up of the panels, and then we have got an inverter which converts the incoming DC power to AC power, and then straight away we can supply some of the loads that are local to our station, and also we can push into the grid. So such a system is classified as a grid connected system. It is classified as a grid connected system. The architecture of such a system starts with the solar PV panels, which are strings or array of solar PV that feeds into our inverter system. So our inverter system has got an inbuilt conversion of DC to AC without an intermediary of a battery system. So in conventional terms, in conventional systems, in microgrids or in conventional grid connected systems, these types of inverters can be classified as PV inverters. They are classified as PV inverters because their primary objective, their primary function just interlinks your DC power from the solar panels into your grid, or supplying your associated loads that are local to your generating station. So such a system, you expect it to just operate during the day when you have got power coming from your solar panels. During the night, when you don't have power from the panels, you don't actually have power coming from your system. But if we look at another configuration, which also is a solar PV system, the balance of components changes. So when the balance of component changes, we have a configuration with the addition of a charge controller and also storage. So in such a system, we basically can arrange this system into an off-grid connected system, or in certain cases, this can also be linked to the grid system to form an hybrid system. But for the sake of this small introductory part, so what we have for this off-grid system is the PV panels. Primary objective is to produce DC power from sunshine, and this happens during the day when we have got irradiation that is hitting the solar panels. And then we have got a charge controller which basically regulates the power that is coming from the PV panels. So the charge controller will actually feed some of its power direct to DC rods. So you can have DC rods and they will be fed direct from the charge controller. Also, the inverter is fed with a DC power, which is converted to AC power to feed your associated AC loads. And then we have got storage. So storage actually stores your energy during the day when you have got production. And then during the night, when you are not producing anything, as we had seen from the grid connected system, in the night, we don't have anything coming from the panels. But the balance of power changes. We have got the battery giving the inverter and also giving the associated AC loads. Also, you can have some DC loads also being supplied from the storage during the night when we don't have production. So in a nutshell, we have got a grid connected system and we also have an off-grid connected system. A combination of these two types of systems give us what we call an hybrid solar system, which will be discussed later in the next series of the introductory lesson. From me today, thank you and continue with your lessons as we continue to give you more information concerning solar PV systems. Thank you.